Hello dear students. So let us continue our discussion with the nuclear transmutation. So nuclear transmutation is a process of conversion of one element into another element. So this discovery, that is the conversion of one element into another element, that is the nuclear transmutation, so was discovered by the Rutherford. So when high energy alpha particles are released from the polonium, interact with the nitrogen, forming a nuclide of oxygen with the emission of proton. So here you can observe the nitrogen atom, so which is called as the target nuclei. So when the high energy alpha particle, so which is called as the projectile, is released onto the nitrogen atom, so this nitrogen atom is converted into the oxygen, so which is called as the product nuclei, by emitting a proton. So the notation of the above equation can be represented as nitrogen alpha comma P of oxygen 1718. So that means, so this representation can be explained as the when a high energy alpha particle strikes the nitrogen nuclei, so the oxygen is formed by emitting a proton. So it is called as the alpha P reaction. So in this equation, the target nuclei is written first, okay, so followed by the bracket in which the projectile is written and the emitted particle is also written, and finally the product nuclei. So let us consider one more reaction. So when the beryllium is the targeted nuclei, so when the high energy alpha particle strikes the beryllium, so the beryllium is converted into carbon by emitting the neutrons. Okay, so the nuclear reactions can also be brought about by using other projectiles such as the high energy particles like the protons, deuterons, neutrons and the photons. Okay, so here in the first example, so you can observe the reactions, so that is nuclear transmutation reactions, so that involves the proton induced. So these reactions are brought about, or these conversions can be brought about by inducing a proton. So in the first example, you can observe the neon. So when it strikes by the proton, so the fluorine is formed by emitting an alpha particle. Okay, so this reaction can be represented as, this is the target nuclei. So the proton strikes, it is the projectile, and alpha particle is emitted, resulting in the formation of fluorine. So this series is called as the P comma alpha series. So in the second example, the copper is the targeted nuclei. So proton, when it strikes the copper, so the copper is converted into zinc by emitting the neutron. So this can be written as the copper P comma N Zn. So it is called as the PN reaction. So in the second example, so you can see the deuteron induced reaction. So in the magnesium is converted into the sodium, so by the striking of the deuterium. So here the magnesium is the targeted nuclei, deuterium is the projectile, alpha is the particle emitted, resulting in the formation of sodium. So here the deuterium strikes the potassium, resulting in the formation of potassium 4219 with the emission of a proton. So this can be represented as the potassium as the targeted nuclei, deuterium is the projectile, and a proton is emitted, resulting in the formation of potassium 1942. Okay, so in the next example, neutron induced reactions. So a neutron strikes the boron, resulting in the formation of lithium emitting an alpha particle. So this reaction can be represented as boron, it is the targeted nuclei, neutron is the projectile, alpha is the particle emitted, resulting in the formation of lithium. So this series can be called as N comma alpha series, or reaction. Okay. So then the next example, when the neutron strikes the cobalt, so it is converted into cobalt 2760, emitting the gamma particles. So that is, so this reaction can be represented as the cobalt 2759 is the targeted nuclei, N is the projectile, and gamma is the particle emitted. So this series can be called as the N comma gamma series. So in the next example, the photon induced, so that is gamma ray induced reactions. So when the copper strikes, that is the gamma rays strikes the copper, it is converted into one more isotope of that is copper 2962, having a mass number 62, emitting a proton. So this reaction can be represented as copper as the targeted nuclei, gamma is the gamma rays are the projectile, neutrons are emitted. So it is called as the gamma comma N reaction. So in the second example here, so in this example, so the gamma rays strikes the aluminum. So aluminum is converted into magnesium by emitting a proton. So this reaction can be represented as aluminum as the targeted nuclei, so gamma rays as the projectile, and a proton is emitted that results in the formation of the magnesium. So this reaction can be called as the gamma comma P reaction. So the nuclear transmutation led to the discovery of the artificial radioactivity, nuclear fission, and the synthesis of transuranium elements. So that is the elements which appear after uranium in the periodic table. Okay. So let us see what is artificial or induced radioactivity. Okay. So artificial radioactivity can be defined as the phenomenon in which a stable nuclide is converted into a unstable nuclide by bombarding with a suitable projectile, that is high energy molecule. The bombardment of aluminum with alpha particle resulting in the artificial radioactivity. So here we can explain by using the example of aluminum. Okay. So once again we shall see what is radioactive, artificial radioactivity or induced radioactivity. So when a stable nuclei, it is the phenomenon of conversion of a stable nuclei into unstable nuclei by bombarding with a suitable projectile. So which is called as the artificial or induced radioactivity. So let us consider the example of aluminum. So the alpha particle bombarded with aluminum results in two types of nuclear reactions. So one reaction involving the release of the protons and the other resulting in the release of the neutrons. So here you can see, so when the aluminum is bombarded with the helium, that is projectile, so it forms the silicon by emitting the proton. So in the second example, when the aluminum is bombarded with the helium, it forms the phosphorus by emitting the neutron. So this phosphorus which is formed is said to be unstable. Okay. So because this phosphorus contains odd number of both protons and neutrons, so it is highly unstable, and this phosphorus will undergo spontaneous radioactive decay. Okay. So like any other nuclide with the emission of the positrons. So that nuclide will have a half-life of 2.5 minutes. So here you can see the unstable phosphorus nuclide undergoes radioactive decay to form the silicon. Okay, with the emission of the positrons. Okay. So similarly, a similar phenomenon we can notice by the alpha particles bombardment of targets such as boron and magnesium. So here you can see when the boron is bombarded with the alpha particle, it forms the carbon and the proton. So when the boron in the another reaction, so when it is bombarded with helium, it forms nitrogen having the atomic number 7 and mass number 13 by emitting a proton. So this nitrogen having the odd number of protons and the neutrons, protons and neutrons, so it is said to be unstable. Okay, so in this example, the magnesium, when it is bombarded with the alpha particle, it forms aluminum, so which is stable. So when the magnesium, when it bombarded with the helium, it forms silicon having the mass number 27. It is said to be unstable. Okay, so in this nucleides, so there are less neutrons than the required for stability. So this unfavorable N by P ratio changes into the favorable one with the conversion of a proton into a neutron and a positron, and the positron thus released is ejected. Okay, so in these above examples or reactions, so the unstable nucleides achieve stability by the emission of the positron. So the artificial nucleides can also achieve the stability by the emission of the electrons. So here you can observe this example. When the magnesium is bombarded with helium, it forms aluminum having the mass number 28, atomic number 13, so which is unstable. Okay, so aluminum having the mass number 28 and atomic number 13. Okay, so it undergoes the decay to form the stable silicon nucleus. Okay, so the artificial radioactivity can also be produced by bombarding with protons, neutrons or photons. Okay, so here you can see in the example, boron is bombarded with proton to form unstable carbon. And in the second example, the sodium nuclei is bombarded with deuterium to form the sodium.